Awesome. Welcome to API Days Australia. My name is Jeremy Snyder. I'm the founder and CEO of a company called FireTail. We do API security software. And unsurprisingly, today I am here to talk to you about API security. But more specifically, what I want to talk about today is analyzing breaches and then what we can learn from breaches to empower developers to build and ship more secure APIs. Because ultimately, at the end of the day, the configuration of our APIs mostly lies in the hands of the developers. And we're going to talk about why that is where we need to be focusing a lot of the effort around improving the security of APIs overall. So in the next 20 to 25 minutes, I'm going to give a little bit of a background on some of the lessons learned. We're going to analyze some of the breach data analysis that we've done over here at FireTail. We're going to talk through a couple of specific examples of some pretty high profile incidents, whether breaches or responsible disclosures. Then we're going to talk about a few security strategies that really do work and are proven to kind of work in the real world. And then that question about bridging the gap. How do we go from just having developers who ship APIs to having a real DevSecOps approach where we incorporate data from developers, from security, and from operations? We bring that all together into one process where we can be constantly improving the security of our APIs while actually increasing our ability to ship more frequently and improving our overall operations. And then, on this video, unfortunately, I don't think we're going to be able to do Q&A, but you will definitely have a chance to ask any questions that you might have of the FireTail team if you're live at API Days in Australia, or just reach out to us anytime. So just reach out, info@firetail.io, with any questions. We'll be more than happy to answer those for you. You can also hit us up on our LinkedIn page. And then we've got a couple little bonus offers to put out there for anybody watching this talk, especially those who will be live. So just a couple quick words about me. I have been in IT and cybersecurity for about 25 years. I spent the first half of my career as a hands-on keyboard cybersecurity practitioner and leader, first with a couple of software as a service or SaaS companies, and then with a video game company. And throughout that time, I kind of learned a lot about security, both from the standpoint of some of the very basic blocking and tackling, like, hey, implementing AV across all of the desktop and laptop systems within an organization, into incident response and responding to breaches. And I have had my share of breaches across some of those companies. And then I transitioned into more kind of customer facing roles, starting with AWS at a time when cloud was still a very new concept where a lot of people had a lot of skepticism about how real cloud was. And I've kind of stayed in the cloud ecosystem ever since, with about the last 7 years spent specifically focused on cloud security. And as part of that journey, what we really observed was a change from my first days in cloud back in 2010 to how customers are using cloud today in 2023. And the way I like to think about that is we've gone from kind of cloud 1.0, which was really a lift and shift. Let's kind of replicate our data center over into the cloud, to now more of a cloud 2.0 model where we think about what is an effective use of all of the different resource types provided by the cloud vendors like Amazon, Microsoft, and Google. They've got this whole broad range of services that do everything from all kinds of compute to storage to database to network, et cetera. And what we see now is we actually see a really strong embrace of cloud native architectures that rely heavily on microservice designs and patterns, and there we do see increased adoption of things like serverless and containers. And all of it is fronted by APIs. And those APIs sit on a network, and they provide access to data sources, and they provide access to business functions. And we're going to talk about why that's important in some of the breach examples, and we're going to talk about what we can learn from those breach examples and how we can do better. So to start off with, we spent about, I don't know how many hours, but some tens of human hours looking over a decade of API data breaches. So we've been tracking this on our website. You can see the URL there at the bottom of the screen. If you want to have a look, feel free to. And the first kind of publicly disclosed API-based data breach that we could find was back in 2011. And unsurprisingly, in the years from kind of 2011 to 2017, there weren't that many disclosed API-based data breaches. But what we've seen kind of in the years since, from let's say 2018 through today, is really rapid rise in the number of API-based attacks and the number of API-based kind of leaks, breaches, exposures, whatever you want to call them or however you want to think about them. And you can see the growth rate is really staggering. There was a Gartner comment a couple years back, or a Gartner prediction, I should say, that APIs would soon become the number one attack vector. And really interestingly, just to take a second, talk about a tangent here, earlier this year, I gave a talk where I said that did not come to pass. And some people at Gartner actually saw my talk and reached out, and they actually shared some follow-up analysis that they had done, both Gartner and IBM. And they actually kind of came back and showed me the data to say, in fact, APIs are actually implicated in most modern attacks. And we're going to talk about a couple of examples of things that you may not think about as API-based data breaches or API-based attacks, but that have very, very strong API implications. And so I think actually that prediction is coming true. And one of the things to think about, like why would that be the case? Well, APIs actually represent about 90% of the attack surface of modern applications. When CISOs are asked about what are the risks and the challenges around APIs, the top 6 that came back in a survey from CSO magazine, Chief Security Officer magazine: lack of API inventory, lack of visibility, right? So that's a very common problem with new technologies. One question is enforcing perimeter security as well. What does that actually mean for APIs when many APIs are designed to sit publicly exposed? If you think about every mobile app that you might use, especially those that have location basis, you might connect to them from anywhere in the world. I'm giving this talk in Australia, but I might pull out Uber to request a ride share here, even though my Uber account is tied to the USA. So the API for the Uber app has to be open for me to connect from anywhere in the world that I might be. And then based on my location, it'll show me services. So what's a perimeter, a proper perimeter around that API that has to be available for me to connect to it? And then third, end-to-end tracing of code to APIs. This comes back to my point earlier about how so many of the breaches really come down to things that are only in the control of the developers. And we're going to talk about some specifics there. Along with that, the number of required security configurations for APIs, I think that is very heavily connected to the fact that most APIs are being written, launched, and deployed on modern cloud applications. And or cloud platforms, I should say. And when we think about cloud infrastructure and where the risks are, we find that it's actually misconfiguration that is far and away the number one risk around cloud breaches and cloud data leaks. And then API change management. This comes to the common disconnect between development teams and security teams. How do we run a proper change management process with an update to an API, maybe a deprecation of a previous version of an API? How do we communicate? How do we coordinate that? And what are the implications for the broader environment where that API lives? And along with that is really that ongoing gap between developers and security teams. So not a lot of new risks posed. These are actually a lot of the same risks that we've seen for the past 10 plus years, especially around cloud environments, but now applied to APIs. So following up on the breach data, we released the first version of our State of API Security report in May of this year. We actually just went back through and analyzed some of the updated data around that. One of the craziest things to see was that the number of records either breached or at risk of breach has almost tripled just this year. And the volume of records per data breach is actually going up. And I think that is partially a function of the overall data volumes growing, so that kind of the volume of data that's in databases fronted by APIs is growing. But we're also seeing just a huge acceleration on the number of attacks targeted towards breach events. So we broke down the top attack vectors in these API breaches, and we found that number 1 and number 2 are authentication and authorization. What's interesting about that is when you think about where authentication and authorization live, you'll find that they're almost always tied to the logic of the application. There's a couple other aspects here that I will say. So governance, enumeration, these are also things tied to kind of the configuration of the application, some implication towards the business logic, but authentication and authorization are number 1 and number 2 by a wide margin, I would say, as well. So if you look at that data, you'll see that as well. One of the other conclusions that we found was that almost all breach events are multi-vector. So let's talk about that for a second. We, along with our primary cause of breach, we analyzed a secondary root cause where one could be assigned. And what's really interesting is that, if you've got authentication and authorization number 1 and number 2, you've actually got authentication and authorization very high as a secondary breach vector as well. So sometimes the two actually go hand in hand in terms of representing a problem for a specific API or in a specific event. So let's talk about some of these events. So there was a pretty public event in 2021, 3 million records exposed from Peloton. This is kind of interesting. Peloton was a very high-flying brand name at that point in time. We were kind of in lockdown, a lot of home exercise equipment being sold. And what we saw was a couple of things that went wrong there. And if you ever want to test this for yourself, it's really easy. Pull up any mobile app or any smart home device or connected device or IoT device, whatever you want to call it. Use it on your home Wi-Fi and then just go on the router of your home Wi-Fi and look at the logs. You can actually see the API calls being made. So the attacker in this case looked, and what they saw, just to kind of put it in simple terms, they saw, let's say, like a user ID equals 1, and then another argument in the API call that says profile ID equals 1. Thought to himself, well, what happens if I change profile ID to 2, to 3, to 4? And so what we saw there is there's sequential numbering, integer-based numbering, and the fact that there was no post-authentication follow-up request to authorize, because what should have happened is you say user ID equals 1, profile ID equals 1, no problem. But user ID equals 1, profile ID equals 2, no, that's not allowed. Why can user 1 see user 2's profile? That shouldn't be allowed. So there's a common problem, and we've seen this across a lot of the data set, where authentication and authorization often get either kind of confused for each other, or where we don't see authorization checks happening post-authentication. And really, the practice to learn there, the takeaway there is that authorization has to be done server-side. It has to be done with every call, and it should start with kind of a default deny protocol where the API request shouldn't be allowed unless the principal, which is the user making the request, the resource, which is the data being requested, and the action, which would be something like view profile or edit profile or update profile. That would be the action. All of those need to have an explicit yes coming from some permission store. And that permission store is very tightly tied to the logic of the application. And so this is one of the key reasons that we say that actually the breaches are around application logic. So we're not the only ones to say that, by the way. In an analysis that was posted on archive.org from a security researcher, looking at a lot of the same data that we looked at in our data set, they came to the same conclusion. It's vulnerabilities in apps that is the cause. Now, another case that we looked at is Lemonade, where what was called a website bug at the time exposed the data. But what really happened, if we dig into it, was that there was a URL that got indexed. And what happened in the indexing process was that the indexer made a few calls to that URL. It generated a number of API results that ended up in the SERP, which is the Google search engine results page. Those API calls did not require either an authentication token nor did they check for authorization. To top it off, once they got indexed, some people realized that what they were seeing in their browser was actually the result of API calls. And of course, that's very easy to inspect. You can go into developer tools in your browser. You can see actually the API calls being made between the front end, meaning what the HTML display that you get, and the back end, which is the app server serving up the data. Now, with that, they noticed that, okay, we've got some API traffic going on. We could actually issue some follow-up commands using that same API. That API actually allowed for full CRUD functions. So what we've got there is we've got a combination of a little bit of a poor network configuration that allowed for that indexing to happen, and a little bit of crawling around that API. And then we've got really poor authentication and authorization logic around the API. So that kind of reinforces that secondary point that I made from the overall data set analysis, which is that we've got almost all breach events being multi-vector. So just to follow that up with one final example, Starbucks. Now, this case was a responsible disclosure, but what we saw here was a really interesting mix of things going wrong. So what we've got is we've got an undisclosed GraphQL endpoint that was discovered through enumeration. Enumeration in this case meant just issuing repeated queries to API endpoints that either do or do not exist. And what happened was the server was configured in a way that it kept giving back error messages that suggested paths further and further down on the app server logic, on the API endpoint logic to find this GraphQL endpoint. Then the GraphQL endpoint, which was probably not intended to be on a production server, was probably intended for a development environment to test various queries, allowed for the equivalent of a select star query to extract data. So we've got a poor app server configuration. We've got a non-declarative API model that allows for enumeration, when what should happen is that actually, like any enumeration of an endpoint that is not explicitly declared in an API specification should just be drop traffic. And with that, we then have this GraphQL endpoint that gets discovered, and it has a configuration error where it doesn't have, let's say, query depth limitations on the GraphQL endpoint. So we've got kind of multi breach vector happening, and here you can see this comment: the internal API, which would allow an attacker to exfiltrate nearly 100 million user records. Now, again, thankfully, this one was a responsible disclosure, which is good for me because certainly my data is in that data set. We're here in Australia, API Days Australia, but I'm not going to bore everybody because I'm pretty sure this one has been analyzed to death, particularly by people who are in this room. But just to kind of reiterate here, we've got no authentication needed, everything wide open for anyone to use. Couple quick comments around the overall analysis of the data set. Where do breaches happen? While it's not industry specific or geography specific, yes, APIs are everywhere. There is a little bit of impact on some industries that make a lot of sense when you think about them. Technology is a pretty obvious one. Who builds APIs? Well, a lot of software companies build APIs, so there's definitely an overrepresentation of software in the data set. Secondarily, manufacturing. And this has been really interesting because you think about car manufacturers as having a lot of, car manufacturers in particular from manufacturing. You think about car manufacturers as having supply chains for various parts. Well, when you put that into the modern context where we've got connected cars and we've got self-driving vehicles and autonomous cars and a lot of intelligence and data being put into cars, we also now have digital supply chains for these cars. And so that's where we've seen a lot of the API impact. And then finally, hospitality, and in particular, the travel industry, which again makes a lot of sense. You've got OTAs, online travel agencies. You've got kind of aggregators like Expedia or Kayak or Orbitz or whatever it is in the part of the world where you might live. And when you make bookings through those things, you're generally booking not for Expedia to fly you from point A to point B, but you book via Expedia to get a flight on Qantas from the US to Australia, for instance, right? So you've got third-party interactions going on there all the time. This year, we've actually had a huge number of disclosures. Note that in our data set, we do make a distinguishment between responsible disclosures and breaches. So when we look at our numbers, we tend to emphasize breaches as opposed to disclosures. But points.com is an example of that kind of travel industry point that I raised earlier. Points.com is the back end for a lot of airline and hotel loyalty programs. Connected cars, you can look that one up as well. These are all taken from our blog. And by the way, I mentioned earlier that sometimes you think about attacks that you hear about a lot, but you don't realize that APIs are heavily implicated. MoveIT, that one at the bottom there, it's kind of confusing. There are two breaches around the name MoveIt. But MoveIT from Progress Software, the file transfer protocol, the most likely delivery vector for the SQL injection is an API for a resume upload endpoint that doesn't do virus or injection scanning against the payload being sent to it. And that is most likely where the script that kicked off the ransomware attack happened. Again, you probably hear about this one much more as a set of ransomwares, but actually the API was the attack vector on that. Kind of, again, goes back to that point that the API represents about 90% of the attack surface of modern applications. So what do we know about API security, and why does traditional security not work? We took the OWASP API top 10 and we mapped it to a very simple diagram, a simple architecture here. And what you'll notice is that the vast majority of the risks and kind of the attack vectors that you might think about actually live within the server. So this, again, is just kind of reinforcing this point that it's inside the application layer and it's inside the application logic that you see these things. So what we've learned around API security, going back to those top 6 points from CISOs, the number one problem that you have to solve for any security program is visibility. If you don't know that it's there, if you can't see it, you cannot protect it. So we realize that the first 3 components that you need around an effective API security strategy really are discovery, visibility, and observability. So you need to be able to find APIs on an ongoing basis, get a list of your APIs, and then observe them to understand what's going on. How are they being used? Are they public? Are they private? Is there PII going through them, et cetera? Next, you need to be able to assess them from a policy perspective. And this is an area where I think we could actually make an improvement as an industry, because right now on API security policy, there's not a whole lot going on. yes, we've got the OWASP API top 10, but is it policy or is it really just kind of risk categorization and threat modeling of APIs? I'll leave that one for Q&A for later on. And then last but not least is enforcement and audit. And when we think about kind of what a lot of security programs really rely on, they rely on logs and they rely on the ability to do forensic analysis to understand what goes wrong. But when we think about modern cloud environments, logging is all over the place. You might run APIs on EC2 or on Lambda or on Kubernetes, any flavor of Kubernetes service, all of which log to different locations. So centralizing the audit trail is very important. One last point, I mentioned that the threat model maps to a lot of stuff inside the server. Well, we actually compared logs from different types of AWS environments, from EC2, from container and Kubernetes sitting behind a WAF or an API gateway, or getting logs off of the app server itself. And what you'll notice is that from all of the attacks we talked about, when we talk about manipulating request parameters and request payloads or delivering a SQL injection through a request payload, you only get that visibility by looking at the application layer. So how do we bridge the gap and how do we actually make it very easy for developers to ship more secure APIs? Well, I mentioned that we kind of see this adoption path of discovery and inventory, policy assessment, and then we look at kind of implementing runtime protection. Along with that, we kind of want to move from just developers shipping APIs to a DevSecOps model where development works with security and operations in a continuous improvement loop. But what does that actually mean? It means we need to inspect specifications of the APIs, we need to inspect security configurations, and we need to have the ability to do governance and enforcement. So when we think about empowering developers, we need to provide clear guidance. Where is the problem? What is the problem? What's the risk implicated by this problem? And how do I fix it? So from the FireTail perspective, the way we think about that is kind of ongoing visibility and assessment of API environments. You can take what you find from that assessment and you can get very detailed, down to the fact that I know, for instance, that starting around line 600, going to line 602, we've got some problems around a numeric ID in our APIs. Why is this a problem? Well, we know that we've got a rule set that aligns to that, that rates this as a high severity. And we give an example of how to fix it right there very explicitly. And by kind of incorporating this type of assessment process, we can give that data back to the developers who are responsible for building and shipping the APIs so that they can lock down and secure the application logic of the APIs. And if we want to get really advanced, we can actually think about incorporating that into an overall security program that might be predicated around application security or cloud security. So I'll leave it there for today. If you want a copy of the slides here, they should be linked from where you're viewing this talk. If not, feel free to scan that QR code. Also, if you're viewing this in 2023, even post-event, we do have a 60% offer for people coming from API Days Australia. If you sign up in 2023, we can get you 60% off an enterprise plan provision through AWS Marketplace. And we are also offering a free API security assessment to this audience. So please feel free to give a sign up for your chance to win that prize. And with that, I will say thank you very much for your time today and watching this talk. And hopefully that gives some idea around how we can think about incorporating an ongoing process to improve the security of the APIs that we build, ship, deploy, and use every day. Again, my name is Jeremy Snyder. I'm with FireTail. For any more information, please feel free to reach out to me directly, jeremy@firetail.io. And with that, thank you to API Days Australia.